Hi, this is Will Tyrone. This is part of my application for Duke's Masters in Statistical Science. And I kind of just wanted to walk through some code I've written in Python as part of, I took probability and mathematical statistics at the University of Louisville, and part of my interest in statistics is the applied side of things. So I took those theoretical concepts and decided to try to write some code to actually apply them. And you can see, if you visit my GitHub, uh, Will Tyrone, and the applied stats repository, you can find what I'm working with. And I'm going to talk through this like the viewer knows a little bit about Python and open source programming, but if you don't and you need a little more context, feel free to contact me and I can explain anything you need. So, as part of the challenge to myself, I wanted to put it on PyPI so that it could just be installed with pip. So you can just pip install applied stats, and if you visit PyPI, this is a Python package index. So this is where everyone stores their Python code to be, easily installed. So that's what all of these extra files are for, if you're not familiar with Python packaging. And in here, in the README, I have some examples, and I'm going to walk through some as well. So, here's the link for this if you want to look through it, look through any of the code. I will actually go into one of the files, and then we will walk through a quick demonstration. So, I already have it installed, so I'm just going to import the continuous distributions model and the MLE or module. Sorry, those two modules, and they're just part of this Python code that I've written. So the basis of this is that there are classes to define the different distributions of given variables. So for example, I started with a normal random variable. I also have in here classes for chi-squared, t distribution, and an f distribution. And this also came up because in class it becomes increasingly difficult to actually calculate and visualize these probabilities and distributions, just because the formula for the density function is just really long. So I thought, okay, I'll just try to make an easy way that this can be calculated and plotted, just to help myself visualize different probabilities. So you can see here I just assigned, I instantiated this class, and that's with mean 0 and variance 1. So if you look at the documentation again, you can see we have mean and variance in the init class, and then in all of these different methods, I have, pretty built out documentation and then sources from the textbook I was using. So you can also reference this and just see that's the argument to instantiate that. So just by default, we call the plot PDF method and the probabilitycalc method. So it plots the PDF here. So standard normal random variable. We get this nice plot, and then it shades up to the mean by default. So the mean here is 0. And it tells me the probability that the random variable is less than the critical value is 0.5. So obviously, because it's symmetric and we're going just shading everything up to the mean, that's going to be a probability of 0.5. And just a quick walk through the code. I'm not going to go too in depth, but part of the challenge to myself of doing this was that sure, maybe you could do this with SciPy or some other code that's kind of already written, but I want to just write it from scratch and see how I could accomplish that, and just to see what it would end up looking like. So we have the formula for the PDF here, It's being evaluated over a bunch of x points of data just to plot that. And then to plot the PDF, we're filling up to the mean, and then the probability calculation, we use SciPy's integrate function, and we integrate from -infinity to the critical value. So we integrate that density function. So that can then be used, instead of using just a regular z table with z scores and just finding those and trying to figure out the probability, we can actually just integrate those and find a more precise probability, and for any critical value we want. So let's try this with a critical value of -1, and by passing these two arguments, it's going to plot with two tails on the normal distribution. So you can see here that, so I have it to plot symmetrically. So we start from -1. So it's -infinity up to -1, and then 1 to positive infinity. So it shades those areas, and then it also calculates the combined areas under there. And then I also have a chi-squared distribution. This is just an example with 5 degrees of freedom, and I have the same functionality for a t distribution and an f distribution, just in this continuous distributions .py file. So then let's look at an example. I have, we'll go back here. So we have an MLE file, hypothesis testing, and confidence intervals. And the hypothesis testing and confidence intervals are both a work in progress, as the whole package is. So I've just been taking any concept I was learning and adding it in here. So let's take some random data, and we're going to combine the distribution file and the MLE file to calculate some probabilities. So if we have some random data, this is just a selection of it, but just to show you what the data looks like. So I wrote up a basic example. What if we're looking at financial data and the charge amounts or the transaction amounts on a bank account? So a negative value would indicate an expense, and a positive would indicate a deposit or a gain of money. So the maximum likelihood estimators, the MLE for a normal distribution. For the mean, it's just a sample mean, so the sum of observations over n, and then the variance is 1 over n times the sum from 1 to n of x sub I minus the mu hat, so the sample mean quantity squared. So then in the file, we can jump over here and look at the normal MLE calculation, and you can see here all of the documentation. So I wanted to make sure that was all working really well and well explained, so that if anyone were looking at this, they could understand which formula I was using and why I was using it. So we just have the formula written out, and then it's going to return this as a tuple of values. So we're just feeding in this randomly generated data into the mean and the variance, and those will get unpacked. And we have a mean of -$1.04, and then a variance of $27. So then we might ask ourselves, okay, so what if we randomly select a transaction? What is the probability that that's between -$5, so a $5 expense, and a $5 deposit? So we're going to do a similar thing to what we did above, but now with these calculated mean and variance values, or rather the MLEs for mean and variance. So calling the same thing again, just the normal random variable class to instantiate this variable. And then I'm going to use a critical value of -5 because I have it set to plot the plot symmetrically from the negative value. So it'll go from negative infinity up to -5 and then 5 to positive infinity. And then we pass those same arguments in that we did earlier, and we'll calculate it. So it gives us this nice normal distribution. It's almost centered over 0, but you can see it's -$1 like we mentioned above. And then it's showing me that we're plotting it up to -5 and then 5 to infinity. So my motivation was also that this just makes it much easier to visualize when you're calculating something. So it just made it make a lot more sense to me as I was kind of working through all of the theory in class. So this is the probability of the shaded areas, but I set up here, we want to know what between those two values. So because we have these shaded areas, we'll just do 1 minus the complement. And we can see, so 0.774 is the probability that it would be between -$5 and $5. So I hope you enjoyed this short presentation, and please let me know if you have any questions.